Okay, good morning. Welcome to
FamilyMath926.
FamilyMath926. So today we're going to take a look at a really neat idea from actually astronomy that I saw thanks to a Twitter thread retweeted by someone I follow named Chandra Prescott-Weinstein. She's a physics professor at the University of New Hampshire. And the original thread was by Bruce McIntosh, who's a physics professor at Stanford. And we're going to be looking at something called the magnitude, which is a measure of sort of when you look at something in the sky, how bright it seems to you. Okay.
Right.
And it's an interesting scale. It's somewhat non-intuitive because it's based on a logarithm scale, but I thought you'd be interested in learning a little bit about it since you were just starting to study logarithms, right?
Yep.
And you know a little bit about logarithms. Mm-hmm. The scale turns out to be based on the fifth root of 100, which is somewhat curious. I don't really know the history of why the fifth root of 100 was chosen, but it does make for an interesting initial talk, and then we'll look at some of the objects on the Wikipedia page and what their magnitudes are. So the formula, really we'd be looking at log base fifth root of 100, but we can simplify that a little bit and say the change in magnitude from the object you're looking at to a reference object that you know is minus 2.5 log base 10 of the intensity of the light divided by the intensity of the light coming from the reference object. Okay. So that means, since this is based on the fifth root of 100, if we take log base fifth root of 100, of x, of some number x, this is the same as, do you remember your log formulas for what if you're doing log base a of b, that you can switch this out to something?
You can switch it out to log base whatever you want of b over log base whatever you want of a.
That's right. That's right.
And I think they chose log 10. Or
yeah.
10 for,
So here they choose log base 10. And so this is going to be the same as log base 10 of x over log base 10 of the fifth root of 100. Right?
Mm-hmm.
All right.
And let's see if we can figure out, maybe you can tell me what log base 10 of the fifth root of 100 is. What is log base 10 of 100 to the 1/5 power?
Well, 100 is 10 squared, so this is really 10 squared to the 1/5.
Very good. So this is log base 10 of 10 squared, whole thing to the 1/5. Yeah.
So this becomes 10 to the 2/5.
Very good. This becomes 10 to the 2/5.
Since you're looking for what power of 10 equals fifth root of 100, so it's 2/5.
So this is 2/5.
Yep.
Very good. So instead of having log base 10 of 10 to the 1/5 on the bottom, we have 2/5 on the bottom. And that turns into, if I have 2/5 on the bottom, what do I really have? What's another way to write 2/5 on the bottom?
So it's multiplying by 5 halves.
5 halves, which is?
It's 2.5.
2.5. And again, for reasons I don't quite understand, they've chosen to take the negative of this. So the negative, I think, was just a choice. They decided to take the negative.
Just to make the scale work a certain way.
Yeah, yeah. So this is how we get our formula that the change in magnitude equals minus 2.5 log base 10 of the ratio of the magnitudes. So what was it? Intensity 1, the thing you're trying to measure, over the intensity of the reference. Okay, so good work. So now we don't know why they chose the fifth root of 100 as the scale, but they did, and we now see where that minus 2.5 comes from.
Yep.
So now let's go to Wikipedia's page and look at some of the magnitudes, and then we're going to look at this Twitter thread.
Alright.